That's today? She scanned them. Oh, yeah. From Monday?
Okay guys, we're gonna start now, so. Alright, so basically we're gonna do a slow reveal graph today. And this will help you guys with stuff like ACT and just looking at scientific data. Because we're just learning how to interpret graphs is super key for all that. So basically we're just gonna slowly reveal information on this graph, and every time I add new information, I want you to write down on your yellow sheet of paper like what new information you're seeing. So right now for this first slide, can you just write number 1 down on your sheet of paper, and then write down what information you see in this graph. Even though it's not a ton, you can just write down what you know about the graph. And then also I want you guys to think about what type of graph this is. And I'll give you 30 seconds to do that. Yeah, go ahead, yeah. All right, okay, can I have what did you guys see about this graph? It has dots? A dot plot? Okay, that's true. So yeah, that would be called like a scatter plot. Yep. Yeah. Yeah, it's linear and increasing. No, that's great. Yeah, exactly. And you can see it's not a perfect linear, and it's not perfectly linear, but yeah, it's generally increasing with a few dips in there. Anything else? Oh, yeah, and then like you said, yeah, we have that red line right there. That's basically flat and not changing. And then I want to note that, so basically this could be interpreted as a line graph because you see that we have those red lines. We have the red line and blue line, but because it's individual dots, you could also kind of view this as a scatter plot. So it's basically a scatter plot that looks exactly like the line graph. All right. All right, this is the next piece of information. Here guys, can you put your phones away for this, please? Thank you. And then next, this one's short, we just got some new information about the x-axis, so you can write down number 2 on your sheet of paper and what information we gained. Yeah, let me know if I'm getting improvement or anything. Okay. Guys, 10 more seconds for that. And then what new information did we show in this graph? Yes. X is in years. Yeah, exactly. So yeah, we have our x-axis is in years. And yeah, that's pretty much in science, just in general, time is probably the most common x-axis you'll run into. All right, so now we're on number 3. Write down what we learned. And you can see the red dot represents natural emissions. And then also, based off this, now that we're kind of learning what the graph could possibly about, you also write a guess about what you think this whole entire graph could be about. And then we'll share that out in a second here. Aaron, do you have a guess about what this graph could be about?
Natural emissions.
Yeah, and then, so yeah, this red line is natural emissions, but what do you think the blue line could be then?
Human emissions.
Yeah, human, yeah. yeah, that's a super good guess, and that's pretty much what it's going to be about. So yeah, that's a good clue. And then if this is human emissions, you can see we're emitting a lot more than what is naturally emitted. All right, so here we go. Now you can write 4 on your paper and write down our new information. Now we got the y-axis, which is going to be ozone depleting substances. And the title of the graph is, again, ozone depleting substances. So go ahead and write that down. Go ahead and click to the next one. Okay, so now we pretty much have a complete picture of our graph. So kind of like Aaron predicted, we have total emissions as the blue line, which represents all emissions that are happening globally, including natural emissions and human emissions. So go ahead and write down on your sheet of paper what are the trends you're seeing on this graph and what those mean. And we'll talk about those in a second. Like, what is the story that this graph is trying to tell you? What did you write down for what's the story this graph's trying to tell?
I said natural emissions make up and contribute very little to the total number of emissions.
Yeah. Oh yeah, that's perfect. So yeah, you said that the natural emissions are a really small part of the total emissions. Oh yeah, and then Richard?
And then all ozone depleting substances emission is due to humans.
Yeah. Oh yeah, no, that's a great point too. That yeah, pretty much all of these emissions are due to humans. Yeah, they're not. So yeah, again, this shows we were doing a ton of damage to our ozone layer. All right, great job interpreting that, guys. All right. Okay. Oh, it's fine. So now I revealed some more data of the graph, so you can see that we were looking from 1960 to 1990. And we saw a clear increase in ozone depleting substances being emitted. But now, at around 1989, we saw a sharp decrease. So you guys think about what things could contribute to a decrease in ozone depleting substances emissions. You can go ahead and write that down for like number 6, I think we're on. Just like what do you think it contributes? I'll give you 30 more seconds to think about that. Okay, all right, guys. Hey, let's focus back up. We're almost through this. But Kaylee, what did you write? Why do you think this happens? Wait. Got it. Okay, thank you. Oh, so you're saying, so yeah, the emissions did decrease, but did you come up for a reason for why you think this happened? No? Okay. Okay, no, that's okay. Did anyone else come up with a reason? Yeah, Asher. Yeah, no, exactly. That's a good point. So, like, changing how much we're emitting is what you're saying. Yep. And did you come up with what are some ways we can change how we're emitting, how much ozone depleting substances we're emitting? Yep.
Using more like energy efficient like resources or resources for like methods, like I guess like electric vehicles, stuff like that.
Yeah. No, that's great. Yeah. Yeah, just reducing like more efficient technology. Okay. Yeah, Rich.
And like reducing fossil fuel burns, like gas and stuff.
Yeah, no, exactly. But so yeah, reducing all those things does reduce emissions. But one thing I want to note is this graph specifically talking about ozone depleting substances. And I'm not a mega expert in this, but I'm assuming there's like certain substances like CTR that contribute to the ozone layer. And things like fossil fuels, though they're super bad for the climate, they may not affect ozone depleting substances. I mean the ozone layer as much. But they're still great things to do. But I'll tell you what happened in 1989. So scientists realized that that human activity were affecting the ozone layer. And though we all kind of know that climate change is a thing and we affect the environment a ton today, I think just finding this out for the first time must have been a pretty crazy discovery. Yeah, sure. Put your name on the board. But so I think that it's pretty crazy to think that us humans, just like one species on this planet, have the ability to just affect our ecosystem so much that we can rip holes in the ozone layer. Like that, I think that's pretty crazy to think. So, but after scientists figured out, they rightly decided to come together and discuss the problem, and they came up with the Montreal Protocol in 1987. And what they did is they basically just, kind of like Asher was saying, they just reduced the use of techniques and technology that emits ozone depleting substances. And not only did this really help in saving the ozone layer, it also reduced climate change by 0.5 degree Celsius. And this is a huge deal because in today's world, the Earth's only warmed 2 degrees Celsius. So if we had another 0.5 degrees Celsius, that would be a 25% increase in climate change compared to what we're seeing today. So that's a huge deal we did this. And then again, there's our graph. And here's what the graph looks like in the scientific website. And the only new thing I can see here is that it predicts, well actually it's already past 1 point, but you can see that it's projected to keep decreasing. The emissions are projected to keep decreasing, which is great news. And then also, just to visualize, you can see that, wait guys, we're almost there, but we have, so in 1980, the ozone layer was doing fine. And then you can see through the years, the hole starts to form, which is represented by this red circle in the middle. And that's the part where the ozone layer is most damaged. And interestingly enough, we know that we started the Montreal Protocol went into effect in 1998, or 1978, I think. And it still caused tons of, and the ozone layer was still getting more damaged, even while the Montreal Protocol was in effect. So that shows that even if you reduce emissions, if you keep adding emissions to the environment, you're still going to be doing tons and tons of damage. And also, it takes a lot of effort to actually change the climate. So even if you do go to zero emissions right away, you would still have lingering effects of past emissions. So those are some of the reasons why the ozone layer is still getting worse. And luckily though, according to the United Nations, the ozone layer the recovery is on track. So we're not likely to die by solar radiation anytime soon, which is good to know.
Can it repair itself?
The ozone layer?
Yeah.
Yeah, well it repairs itself over time as long as you don't mess with it. But yeah, it can repair itself. But it's gonna, obviously we can't do any more damage in the meantime, because we hurt it way faster than it naturally can form. Okay, and then this is the last graph I want you guys to look at. So just take a moment and try to think about what this graph could mean. And this one's definitely a little trickier to interpret, but go ahead and take a minute or two and write down on your yellow sheet what you think this means. And the key is all these lines represent different policies that affected emissions of ozone layer affecting material. So yeah, go ahead and take the next minute or two and write that down.
Are we just writing down what we see?
We'll try to write down like what the meaning of the graph is, as well. Yeah, you can also write down what you see too. But we're just trying to get meaning now. I'll give you guys about another minute to think about it. But come on, Dylan, try to write something down. Oh, you did? Okay. All right, well, Dylan, what did you write down for this graph?
It shows what the protocols do to different areas.
Okay. Oh yeah, no, that's exactly right. Jocelyn, what did you write down?
That it shows the solutions that cause molecule changes.
Okay, yeah, no, those are all good points. All right, sweet. Sounds like you guys were getting the general idea, but this graph was even a little confusing for me at first, but I'll break it down even more so. This black line represents where our ozone depleting emissions would be at if we didn't do anything, which is looking pretty bad. This would not be good for humanity right here. This is if we just stuck to the Montreal Protocol that was founded in 1987. Then each additional line is where emissions are at as we add different laws and regulations. So for example, we saw a huge decrease in emissions just by London banning a few substances, and then Beijing banning some too. And finally, this red line is where we're currently at today, which is great news because we're pretty close to that zero emissions line. Yep.
So it's all like the different protocols that and like how much it helps.
Yeah, exactly. You gotta view it as a story, like no protocol, just Montreal, then with London and Montreal. So yeah, so this red line represents all of those protocols together. Does that make sense?
So they're not, so they're places or.
Well, they're more like laws, but like those are the places where the laws were enforced and enacted. Because like, yeah, because London banned a ton of substances and it made a huge difference. So yeah, it's kind of places where the laws happen. All right. Well, are there any remaining questions on that, or are you guys good? All right, sweet. So now we have a short, it's like a 4.5 minute YouTube video about more about the Montreal Protocol. And I'll put that on real quick.
In our long history,
Make sure you're paying attention to this, guys.
unprecedented act of humanity in which every country on earth came together to protect the future of life